Welcome to The Explainer. Today we're unpacking the truly incredible story of how a single company in Taiwan controls the digital world, sitting right there in your pocket. We are looking at a business that doesn't just participate in the global economy, it is the absolute foundation of it, TSMC. We're going to break down their highly unlikely history, the mind-bending science operating inside their factories, and the intense geopolitical storms brewing around their facilities. Really, this is a story about the absolute limits of human engineering and the fragile supply chains that keep our modern world turning. Because honestly, without this company, the devices you and I rely on simply wouldn't exist. Take a look at the smartphone you use every single day. If you check the back or if you look at your laptop specs, you're going to see massive, familiar brand names, right? Apple, NVIDIA, AMD. But here is the wild open secret of the modern tech world. Those household names don't actually manufacture the physical brains of their own devices. They design them. They lay out billions of microscopic pathways on a computer. But when it comes to the incredibly complex physical creation of those chips, literally turning a digital blueprint into a physical piece of silicon, they hand off the designs to someone else entirely. It takes a specialized giant to actually build these modern miracles. When we talk about the absolute most advanced chips on the planet, TSMC, the Taiwan Semiconductor Manufacturing Company, manufactures a staggering 92% of them. 92%. All other companies in the world combined make up just that tiny 8% sliver. And by advanced, we mean the components running massive artificial intelligence models, the processors powering quantum computing research, and the chips inside the latest military defense systems. Almost every cutting-edge technological leap happening right now is entirely dependent on TSMC's manufacturing lines. They have essentially cornered the market on the future, making them the undisputed king of a ruthlessly competitive industry. To really understand the sheer stakes here, the global semiconductor market is now projected to surpass $1.5 trillion by 2030. This exploding AI-driven market, fueled by everything from generative AI tools like ChatGPT to the massive data centers required for autonomous driving, makes understanding TSMC absolutely crucial for our entire economic future. We aren't just talking about consumer electronics anymore. This is the foundational infrastructure of the 21st century. TSMC isn't merely riding this massive wave of technological adoption, they are the ocean it's crashing in on. Every major tech giant is currently standing in line, desperately waiting for their capacity. So how do they pull off this absolute monopoly? Well, we have to look back to the 1980s and the highly counterintuitive strategy of founder Morris Chang. Back then, the prevailing industry mantra was real men have fabs. Basically, if you were a serious tech company, you manufactured your own chips in your own fabrication plants. But Chang, who had spent decades climbing the ranks at Texas Instruments, saw things differently. When he founded TSMC in 1987 in Taiwan's Hsinchu Science Park, he took a massive calculated gamble. He recognized that building these fabrication plants was becoming so ridiculously expensive that brilliant chip designers simply couldn't afford to bring their breakthrough ideas to life. To solve this, TSMC invented what is known as the pure play foundry model. They made a radical promise. They said they would never, ever design a chip that competed with their customers. They offered a completely neutral manufacturing platform. Think about it. Before this, if a small startup wanted to build a chip, they had to ask a massive competitor like Intel to manufacture it for them, which obviously risked their intellectual property. TSMC changed the game entirely. Because of this neutral stance, companies could focus entirely on design and let TSMC handle the multi-billion-dollar manufacturing headaches. This single idea effectively birthed the modern fabless tech industry, allowing giants like Apple and NVIDIA to thrive without owning a single factory. Morris Chang summed up the approach perfectly. He said, "Our strategy is simple. We are everybody's foundry." That neutral platform built absolute trust, and trust became TSMC's ultimate strategic superpower. By aggregating the manufacturing orders of dozens and then hundreds of smaller design firms, TSMC achieved production volumes that vastly surpassed any single traditional competitor. And in manufacturing, volume is literally everything. Producing more chips allowed them to move down the learning curve faster, identify microscopic errors quicker, become ruthlessly efficient, and then pass those hard-won efficiencies right back to their customers. It created this unstoppable flywheel effect that left competitors totally in the dust. This radically split the tech world in two. Under the old integrated device manufacturing or IDM model, a single company did the whole shebang, the design, the manufacturing, and the selling. It was incredibly rigid and wildly capital intensive. If a company made a mistake in their design, their multi-billion-dollar factory just sat empty. But the pure play foundry model solved this. TSMC became the ultimate specialist.
By decoupling the design from the physical manufacturing, the entire global tech ecosystem was suddenly free to innovate at breakneck speed. Designers could iterate rapidly, knowing TSMC was continually perfecting the underlying manufacturing process.
Fast forward to today, and that hyper-specialized focus has made TSMC the bleeding-edge pioneer of human engineering. And right now, it's fueled by a massive AI boom that is actively reshaping their technological roadmap. TSMC has completely evolved from being a fast follower in its early days to leading the pack. The insatiable demand for AI accelerators, like NVIDIA's massively powerful GPUs, has created a multi-year supercycle. To keep up with the world's desperate demand for faster, more power-efficient chips that can actually train these massive language models, TSMC has to constantly push right up against the fundamental boundaries of physics. Just look at how fast this timeline is moving. In 2026, they roll out their N2, or 2-nanometer node. By 2027, they advance to A16, utilizing backside power delivery to dramatically increase efficiency for massive data centers. And by 2029, they hit the A12 node. We are talking about transistor features so impossibly small, they are no longer measured in nanometers, but in angstroms. We are engineering at the atomic level here. To maintain this aggressive pace, TSMC relies on intense creative problem solving. They're actually intentionally delaying some wildly expensive next-generation tools, choosing instead to creatively extract maximum value from their current machinery to keep costs under control while still shrinking transistors. And the sci-fi reality inside these fabrication plants is truly mind-blowing. First, they're heavily pushing advanced packaging called CoWoS, which is growing at an incredible 80% compound annual rate. This is the delicate art of tightly packing memory and AI chips together to maximize data transfer speeds. If you look up inside a fab, you see the Silver Highway, miles of automated tracks where hundreds of robotic pods called FOUPs zip around carrying precious silicon wafers. And the machines themselves, they use extreme ultraviolet lithography, where lasers strike microscopic droplets of molten tin 50,000 times every single second. This creates purple plasma ignitions that print patterns just a few atoms wide. Achieving this reality-bending precision is why TSMC's capital expenditure might reach up to $56 billion just in the year 2026 alone. Now, because TSMC's most advanced manufacturing is overwhelmingly concentrated on the island of Taiwan, this company is no longer just a commercial enterprise. It is a vital pawn on the global geopolitical chessboard. Nearly all of the highest-end computing power required by the world's superpowers originates from a handful of facilities sitting right on a major geopolitical fault line. This extreme concentration of critical manufacturing capability has forced governments worldwide to realize that protecting, or potentially controlling, the flow of advanced semiconductors is now a matter of ultimate national security. The simple reality is that the modern military, economic, and technological supremacy of both the United States and China runs directly through TSMC's cleanrooms. This brings us to a fascinating, high-stakes concept known as the silicon shield. It's the theory that Taiwan's absolute dominance in global chip manufacturing deters Chinese invasion and ensures allied defense. The idea here is that Taiwan's industry is so essential to global prosperity that it acts as a literal national defense mechanism. According to this theory, Beijing wouldn't want to risk destroying or disrupting the chip supply it desperately needs to power its own economy. And simultaneously, the US and its allies would be fundamentally forced to defend Taiwan to protect their own deeply reliant tech sectors. It essentially holds the global economy hostage as a powerful deterrent for peace. And the potential fallout of a conflict? It's staggering. A Bloomberg report projects a $5 trillion global economic wipeout if Taiwan's manufacturing goes offline. $5 trillion. Just to put that into perspective, that represents a massive chunk of global GDP instantly evaporating. Even just a blockade that stops shipments from leaving the island could cost the global economy $2.5 trillion. Entire supply chains for cars, phones, medical equipment, and defense systems would grind to an immediate halt. The sheer economic terror of that single number is exactly what gives the silicon shield theory its profound weight in international relations. But that shield is currently under immense pressure from intersecting global forces. China is pushing hard for technological self-reliance, pouring billions into domestic production to reduce its critical dependence on Taiwanese chips. Meanwhile, the United States is embracing deep protectionism through the CHIPS Act, offering massive financial subsidies to pull advanced manufacturing back to American soil, basically because Washington views reliance on a vulnerable Taiwan as an unacceptable national security risk. And in response to all of this, Taiwan is shifting tactics, adopting
adopting what's called a porcupine strategy. This is an asymmetric defense plan using agile technologies to deter threats independently, acknowledging they just can't rely solely on their semiconductor industry for absolute safety anymore.
Because ultimately, the Silicon Shield has its limits. TSMC's former chairman, Mark Liu, was very blunt about this. He stated, "China will not invade Taiwan because of semiconductors. China will not invade Taiwan because of semiconductors." It is a stark reminder that semiconductors are not the ultimate deciding factor for war or peace. The historical, ideological, and political motivations surrounding Taiwan go so much deeper than access to microchips. While the economic deterrent is real and massive, TSMC's global success alone isn't an absolute guarantee of long-term security. And that sobering fact is forcing the company into a very difficult strategic pivot.
To satisfy the urgent demands of the US and other nations wanting localized, secure chip supplies, TSMC is now attempting the most aggressive overseas expansion in its entire history. They are rapidly building advanced fabrication plants in Japan, Germany, and the United States. It's a massive attempt to build geographic redundancy into the world's most critical supply chain. But building a fab isn't like building a standard car factory. TSMC is quickly learning that their operational secret sauce, the hyper-efficient work culture that powers their dominance back home, is proving incredibly hard to export to foreign soil. The friction between their traditional methods and local expectations is creating massive operational headaches. Let's look at the financial commitment in Arizona alone. It is unbelievable. $165 billion to eventually build multiple leading-edge fabrication and advanced packaging plants right in the desert. At that price tag, local operational success is absolutely mandatory. They simply cannot afford for this mega project to fail. Yet, getting these American plants up to speed has been plagued by really complex issues. They face regional water scarcity in the desert, immense supply chain headaches for sourcing hyper-specialized chemicals, and most notably, a massive ongoing clash of human capital that is slowing down their aggressive timelines. Building the physical shell is the easy part. Staffing it with the right culture is proving monumental. You see, in Taiwan, their success relies on deeply ingrained high-intensity work expectations. They utilize highly qualified researchers working essentially as PhD foot soldiers right on the factory floor. The expectation is 24/7 on-call readiness to fix multi-million-dollar machines at 3 a.m., driven by a strict top-down execution style. But in the USA, local specialized engineers expect standard 12-hour shifts and a better work-life balance. American workers report immense frustration over high meeting volumes and rigid top-down management styles. This severe friction has actually led to high turnover and a reliance on transplanting workers directly from Taiwan to Arizona just to keep the project moving. And this cultural and operational fragility has very real financial consequences. Let me give you an example. In the third quarter of 2025, an unexpected power outage at a gas supplier in Arizona caused just a few hours of downtime. Now, in a normal factory, you just turn the machines back on, right? But in a fab, a few hours of disruption means thousands of highly complex wafers are instantly scrapped. This one relatively minor infrastructure incident slashed quarterly profits at that specific facility by a staggering 99%. It vividly illustrates how incredibly difficult it is to replicate the hyper-efficient, highly resilient ecosystem they've spent decades building back in Taiwan. So, as AI drives technological demand absolutely to the moon, we are left with a massive question. Can TSMC actually export its unique, highly disciplined DNA to the US and Europe? Or is their unprecedented success, and the Silicon Shield itself, fundamentally and forever tied to the island of Taiwan? The answer to that multi-trillion-dollar question will dictate the pace of human innovation and shape the global economy for the rest of the decade. Thank you so much for joining me for this explainer, and remember to keep questioning the technology you hold in your hands.